Good afternoon, everyone. Welcome to the Google I/O session of introducing Google Coral. My name is Luan. I'm a program manager at the Google's Coral team. On behalf of all my team members, warm welcome to all of you, and many of you watching online around the world. Thank you for joining us. Before I start talking about the Coral product, let's take a quick look of the industry trend, which demonstrates to us why Coral will be important to us. The growth of the smart devices and the so-called IoT, the Internet of the Things, has grown tremendously over the past number of years. And it represents one of the biggest growth opportunities in the years to come. Per many industry trend forecasts over the Internet, such as this one you can see many of those similar on the Internet. The growth of the non-IoT devices, such as PCs, laptops, mobile phones, tablets, and so on, in the next 5 to 6 years will grow from about 11 billion installed units globally to around 12 billion over the next 5 to 6 years time span, representing about 14% growth rate. However, the IoT smart devices, the growth rate from the current install base, about 8 billion units worldwide, will grow to 21 billion in the same period, representing a much larger growth rate of more than 150%. So this really tells us where the growth opportunity and the opportunities for innovation for all of us, for developers around the world, where that lies ahead. Namely, they are in the smart devices. So as the smart devices use continue to grow, the industry interest in smart devices in terms of the innovation and the development will continue to grow. There are several key factors that will drive this trend continue forward. Because number one, due to the increased interest around the world in terms of AI, machine learning, the advancement of research in AI continued to grow over the last several years. In fact, the number of research papers has published in the last few years in machine learning is more than the total number of such papers in the last decade combined. So more AI capabilities will make the application of AI, machine learning on devices, more practical, feasible. As machine learning models become more accurate, faster, performance better, industries will have interest to continue to use them. So as more devices at the edge require machine learning, we really need to have a solution to bring the machine learning onto the device at the edge. We need a technology, especially a hardware, to bring the machine learning acceleration, that capability right on the device. So in a nutshell, smart devices growth demands bring machine learning to the edge, to the device, and we need a solution for that. So let me introduce to you what Google has made for you, for developers around the world, to answer this industrial demand, what we make that possible. Introducing Coral from Google. It is a new, exciting technology platform to enable developers all around the world to build on-device machine learning acceleration AI applications with ease and with high efficiency. So with this introduction session, what you will learn is about what the Coral product line offers, what machine learning capabilities you can build with the Coral platform and the technology. And third, what are the use cases in terms of deploying machine learning with applications in a lot of industry use. So I'm going to go through all these with my introduction here. Coral is designed as make it easier to bring machine learning on the device, make it easier for you to develop applications. It is a platform to make prototyping to production with high speed, with efficiency. It is a platform to develop on-device machine learning. It offers a group of components of hardware components to bring unique high-performance machine learning capability right onto the edge devices. It also offers a complete set of software tool chains to enable you to develop applications in AI, machine learning with ease. In addition to that, Coral also offers a set of ready-to-be-used machine learning models for you to quickly deploy onto devices. So a lot of you may be curious, why it is called Coral? How that has anything to do with AI? Well, if you look at the nature of coral in the natural world, coral really represent a community of vibrant, teeming with life, inclusive, very open community, right? The living organism together, they're working together and they contribute to a common good. And that's exactly what we inspire, want to make an AI platform for the industry, for all of you. So, Coral's inspiration and the mission is to provide a vibrant platform for all of you to collaborate and develop applications, bring AI applications to the device. We want to enable developers everywhere to turning AI ideas to business solutions, from idea to prototyping to large-scale production deployment with ease and simplicity. And finally, we want to encourage everybody joining a community-wide effort to contribute and learn and share machine learning models together. So that's where the name of the Coral came from. So why do we want to talk about the benefits of the machine learning on device? So let's take a quick look at what are the key points of machine learning on device in terms of benefits. Number one, it is a high performance benefit because everything is computed on the device, right on the device locally there. You do not need to send the data back to the cloud, right? So high performance, everything on the local allow you to do things a lot more efficiently. Also, it's very important, very key. In many applications, you want the data to stay on the device, especially in business application scenarios. Some user privacy data cannot be sent to the server, cannot be sent to the cloud. We want a technology to enable you to make that solution available to your customers. And also, because data stays local, every information, all the information coming from the sensors, right on the device can be accessed and used to compute for your machine learning results right there, rather than you have to send the data to the cloud, to the server, to compute and send the data back, right? So this is another way to look at it. It's a much better performance because all the thing, every data is locally available. Next is works offline. There's many scenarios, the Internet of Things, the smart devices, they may or may not have internet connection. In fact, in most cases, they don't have a cloud connection. So you still want to have a machine learning capability in that scenario, and a offline, on-device machine learning capability will make that happen for you. And lastly, it is much more power efficient. A lot of edge devices are small, they don't have large power supply, and they require a high efficiency in terms of computation on the device. Because you don't have to send the data back to the cloud and forth, you save the bandwidth, you save the power to send the data through either Wi-Fi or network. So the benefits of machine learning is very strong on device machine learning, very strong. So let's take a quick look of the Coral product line. What do we offer to the industry? Coral product line offers both hardware components and software components. On the hardware side, it offers development board, and which is a single board computer, allow you to prototype, develop your applications. Also, Coral offers a number of sensors to allow you to build applications using the sensing data in terms of imaging, video, environmental sensors, make those available as a part of the input data to your application. And also, in the software side, we provide a complete set of software toolchain from operating system to SDK to machine learning modules, allow you to easily use them and quickly build your application. In addition to that, we provide a detailed, comprehensive set of contents in terms of documentation, examples, online guide, data sheets, etc. All of those we made available online at the Coral website to all of you. So now we know what the Coral product suite contains. Let's take a look, a little bit more detail in terms of the hardware components. So Coral hardware product, we offer a suite of hardware to you in terms of prototyping and developing applications. The first one is called Coral Devboard. As you can see on the picture here, it retails for about $150. It's a single board computer with operating system on board and machine learning capability right on the device. The second one is a USB key, what we call USB accelerator. It has the Edge TPU machine learning acceleration chip right on the device. You can put this USB into any Linux machine and be able to bring machine learning capability right onto those devices. And I have those with me, and I want to show you the relative size dimension of that. So this is the Coral Devboard. It's very small, as you can see. It is a single board computer with all the necessary input-output, the connectors on that. This is the USB key. It's even smaller. It's just typical to any USB key you would use. So these are the two current computer platforms you use to develop applications. In addition to that, we also offer a couple of sensors, as I said, right, to take the sensing data from the field for your machine learning application to consume. Number one is a 5-megapixel autofocus camera, what we call a Coral camera. Second, we just released a few days ago a new environmental sensor, which is this one here, as you can see, very small, and it has a digital display on that. It allows you to take the input from temperature, humidity, and light, and so on. These input sensors, you can use that and build it for your applications. Now, with these, you do the prototype, but when you deploy these devices into large-scale production environment, we allow you to enable you to take the sound module from the Devboard. In other words, this piece of circuit board can snap off. You can embed it into your product. And this is for volume, large-scale deployment. And the individual unit price, as you can see, for about $115, and we offer discount for volume deployment. Very soon, in the next quarter, we will offer a PCIe connector, a based connector, which you can plug into any PCs or industrial PCs and industrial devices that accept a PCIe connector to allow you to bring machine learning capability into those devices. So those on the left are what you need to do prototyping for your machine learning application. The one on the right is for large-scale deployment. Of course, the cameras and the environmental sensors you could use for both prototyping and the large-scale deployment. So they stay in the middle. All right, let's talk about the Google Edge TPU. This is the center, the core of this platform, bring machine learning capabilities onto the device. So the Edge TPU is a small application-specific circuit chip that Google designed specifically for optimizing machine learning on the device. It is designed to take TensorFlow-like machine learning modules and supports 8-bit quantized TensorFlow model and running on device with a high efficiency. It consumes only 2 watts power, and it runs very fast. The picture you see in the middle represents its relative size to a penny. So it's a tiny chip. And with the sound module of this size, you can easily embed into many, many devices. So how fast this Edge TPU goes? Well, in a general term, what we publish online, the performance speed of the Edge TPU runs computation at about 4 trillion operations per second. So in general term, it's 4 TOPS, if you will. But you may ask, well, how fast it actually runs machine learning model? Take a look at this comparison table. We benchmark a couple of very common, most used vision machine learning models, such as MobileNet, Inception. We're running the Devboard or the Edge TPU USB on both of these, running against powerful CPU or embedded CPU, powerful desktop CPU, such as the Xenon 64-bit CPU or the ARM CPU in the embedded world. As you can see, this table, in comparison, the machine learning capability speed of the Edge TPU runs only a fraction of the time necessary compared to the desktop CPU and the embedded CPU. So it's much, much faster. Now, some of you say, well, OK, this is just benchmark numbers. Do you have an example, real-world example you can show me? And I say, yes. Let me borrow an example from one of our beta users who posted this in our Coral beta online forum. He said, I'm building an app monitoring online traffic in real time, watching 10, 20 cars in real time. I just take the mobile net out of the box without much tweaking and then use the Coral product. I've been able to achieve about 48 frames per second performance. That is very comparable to a 30 frames per second using a GTX 980 GPU plus a CPU, a similar gear. Now, for those of you who build game machines, to build a GTX 980 GPU plus a CPU, you're talking about, what, $500 to $1,000 cost the gear. But with the Coral Devboard, it's only $150, you'll be able to achieve the same results, right? So this really tells you the cost and the performance advantage of the Coral product. So now let's talk about the Devboard a little bit more. Since most of you are engineers, you want to see the technical spec of it, let me go through a little bit. So first of all, the Devboard, as you can see in the picture or in my hand, it is a prototype development board, allow you to directly develop on-board, on-device machine learning capability in applications. It's a full computer. It has a CPU, it has GPU, it has online memory, and it also runs a Linux operating system on this device. It uses a modular design, what we call SOM, S-O-M, system on module design. Meaning, again, you can snap off this SOM circuit board and deploy into your own product. Right? Module design, make it easier from prototype to deployment. It has many I/Os, connectors, allow you to connect to many accessories during the development, make everything really, really easy. So here's a picture of the Devboard. As you can see, it contains all the necessary I/O ports for you to connect to devices, such as HDMI to connect to display, USB connectors to connect to cameras, keyboard, monitors, and so on, as well as Ethernet connectors. It also, of course, has Wi-Fi and Bluetooth to connect to the internet through Wi-Fi. OK, let's talk about a little bit of technical spec in detail. The CPU, it uses a NXP quad-core ARM CPU chip. As you can see, the Cortex is very fast. A53 is a very high-speed CPU chip. It also supports GPU, and it has an onboard encryptable chip, allow you to securely connect to Google Cloud. It has a 1 gig onboard RAM, as well as 8 gig flash memory. So enough space for you to deploy your application. It supports Wi-Fi, Bluetooth, and takes a 5 volts standard power supply. In terms of connectors, it supports both USB 2 and USB 3 speed connections. We support both USB Type-C and Type-A connectors. On the audio and the video category, as you can see, it supports all the AV necessary connections, especially the full-size HDMI 2 connector for a full 1080p video display. It has a micro SD card, allow you to bring more software on board. Has a gigabit network support, and it has a GPIO 40 pin for I/O connection. It supports a special version of the Debian Linux, what we call Mandel, because it's specialized to support Edge TPU functions. And the machine learning models, it supports most of the common vision machine learning models, such as MobileNet Inception, which works great on small devices, on mobile devices. I want to talk about especially this GPIO connection. For many of you who are makers, you're used to making projects using Raspberry Pi, right? Raspberry Pi has this 40-pin GPIO connector. With the Devboard, you can do exactly the same thing. It's compatible to Raspberry Pi 40-pin GPIO. So for all the things you have done in the past, connecting to external lights, switches, using GPIO ports, or using the pulse width modulation to control step motors, everything you've done in the past with Raspberry Pi, you can do with the Devboard, okay? Very, very easily. So how do you use Devboard in terms of development and deployment? Conceptually, it's very easy, as I explained, right? I'm sure you already seen this. So during the prototyping, you use the Devboard, enable all these connectors. You can connect to switches, sensors, temperature gauges, whatever you want. You can connect to a monitor. You can connect to a keyboard. You do development right there because it's operating system running on the device. When you're done, you take off the sound module and unplug from the Devboard. And you can buy many, many sound modules, as I said, right? You can deploy the sound module into whatever the product you are making, such as, say, smart refrigerator, smart washing machine, depends on the application you develop. So this is really easy. It's a prototyping and deployment in one, in a product package, okay? All right, we talked about Devboard. Let me also touch briefly the second product, which is the Coral USB accelerator, which is this little thing here. Again, it's a small USB key you can plug into any USB slot on any Linux machine. It has an onboard Edge TPU, bring the machine learning capability right onto any device you plug into, and also supports not only the Debian Linux, but also the Raspberry Linux, which is similar, or the same one used on Raspberry Pi. So you can plug this and take this key and work with a Raspberry Pi. So it opens up a bit more opportunities for you to do the development. So the Coral accelerator advantages is number one, as you would imagine, right? Bring on-device machine learning into many more machines, okay? You can plug into a laptop if you want, if the laptop runs a Linux, special version of Linux. And then you can plug into a Raspberry Pi. It's compatible with many hardware what the Raspberry Pi supports in the past. So not only PCs, but the laptops, Raspberry Pi, and the industrial systems, that any box supports a USB plug. You just plug this key, and you will be able to deploy your machine learning applications. So the Coral USB accelerator is a low-cost, convenient way to experiment and building prototypes in AI. OK, so we talk about hardware. Let me also talk about the software side. The complete suite of toolchain, what the Coral provides to you to enable you to do machine learning applications. So software components, let's take a look from components level, what the Coral's software pieces and the hardware work together. So on the Coral Devboard, or on a Linux machine, if you will, right? At the bottom layer, you have the hardware, and we have the Linux, the Mendel Linux running on top of that. They talk to the operating system, talks to the hardware. And the Coral, we developed a C++ library, API, direct access to the operating system and the hardware. And so this allows you to have direct access to everything the operating system be able to control for you. Let's say you have a machine learning model. It's a TensorFlow model, TensorFlow Lite model. We provide a Edge TPU compiler, allow you to compile, take a TensorFlow Lite model, compile it into a binary format that is compatible to the Edge TPU. So if you have an application, you can access the CC+ API and running the machine learning model right on the device and access to the low layers of hardware. However, we realize that many, many machine learning programmers like you have been using Python. So Coral software also provides a Python library or Python SDK. It is a high-level wrapper, allow you to using Python programming language to easily access all the features I was just talking about, right? Be able to access the machine learning model, be able to access hardware, and you can write a Python code, do I/O control, and so on. So this is a complete environment with multiple components working together that we put in the product for you to enable you to do AI development. So Python APIs, it's very simple. For many of you who have programmed in the Python, we published this on the Coral website, by the way, the basic classes of all the Python API that you would use for developing machine learning applications. I would say pay attention to the middle two. Those are probably the ones that you would use the most. One is object detection, one is object classification. And the base engine, base class for them is one called a classification engine, one is called a detection engine. So it's very simple. The last one you see here, what we call the imprinting engine, it is something for transfer learning, which I'm going to talk about in a few minutes. It's something allow you to efficiently develop a customized machine learning model, and the Python API library we provided also support that. So let's take a quick look at example. How would you use the Python code actually to interact with the machine learning module models that we supply? So if I say I want to develop a program using the object detection model, in Python code, you will simply initialize the engine using the detection engine, that base class. The base class of the group members, the member functions you use and to get the data and initiate and talk to the machine learning model. So you initiate the engine here. You also need to load the so-called label file, because if you want to detect a bunch of objects, you want to identify them with labels. You load the label file. And then let's say you want to feed the machine learning model, object detection model, with the image. You load the image file. And of course, for most of you who have played with machine learning models in vision, you know you can identify object in a photo, or you can identify object in a video stream. In that case, it will be a vector of tensors. But here I'm using a simple example of just using an image. And then the code to interact with the machine learning model is very simple. The simple line. From the engine, a member class, you just say detect with image. And you pass the parameters to this image. And the return results, the answer come back from this call. You can use it, such as draw a bounding box, specify a color. Drawing a bounding box relates to the stuff that you are detecting. So it's very simple. We supply a group of machine learning models for you to use. Coral include them in the product suite. We put them on the website. They're free for you to download. They are pre-compiled TensorFlow light models that are for you to use. They can be readily run without any further compiling, and you just simply download them into the hardware. The Edge TPU module, the Python module, it is already installed on the Devboard. So you don't need to do anything. You're ready to use your Python programming code. The example I just showed you, you can do that. However, if you use the USB you want to put on a Linux machine, you will need to manually install this Python module. The Python APIs are pre-installed, as I mentioned, right? So that's what you need to do. I do want to mention, though, a lot of those models we supply for free online for you to use, those are for non-commercial use only. That means if you want to build a model, let's say you want to sell for money, that you will need to make your own model rather than use a open source free model that is a non-commercial use, okay? The supplied models include the categories of, as I mentioned, image classification, object detection, as well as a one called weight imprinting. That's, again, used for transfer learning, and I'm going to talk about in a minute. So here are some examples of the models that we make it available for you online. And here are the image classification models, as you can see. We support pretty much all the popular image classification models from MobileNet to Inception, and the different versions of MobileNet, different versions of Inception. The difference between them are the type of objects they are be able to identify. For example, if you want to develop an application to tell the difference between the different birds or different plants, you will pick the corresponding model to use. OK, with that, let me run a couple of demos for you. First demo I'm going to show you is an object detection model. And the second demo I'm going to show you is an object classification model. So with that, videographer, please switch the display to the camera here. So on the table here, as you can see, I have this demo build with this conveyor belt. Okay, I'm simulating a real-time traffic. Over here, there's a camera points to it. As you can see on the screen, the camera feed into this Coral Devboard. In real time, it identifies the number of the objects, right? It shows it's a car, and also shows a so-called confidence score, how confident the model thinks it is an automobile. But on the conveyor belt, as you can see, I also have a people or pedestrian. But what I'm going to do now is I'm going to make this moving, OK? So I'm going to turn on the power, and I'm going to crank up the speed to make that running. Now, in real-time world, as this is moving, you take a look on the screen. The machine learning object detection is continually happening. Okay? It continuously identifies the correct car or pedestrian, or there's a traffic light as well, right? So you can see the Coral performance is very high. Be able to do that as the scene going. Now I want you to pay attention to the lower left corner on the screen, or up left corner of the screen, shows the frame per second speed. It runs, last time I saw, it was like 50 to 70 frames per second. It is very high speed performance. Now, if I crank up the speed and make it go a little bit faster, you can see the machine learning in terms of object identification capturing, it's still going up, right? It continues to be able to identify automobile in this fast-moving environment. So this really demonstrates the power of object detection running right on this Coral device. Okay? So that's the first demo. Thank you. Yes, you can clap. I hope you guys be able to make a lot more interesting applications just like that. Bring the power of Coral into your imagination, into your innovation. All right, next one is showing a object classification. So over here, I have another Devboard, and the output of that display, please switch to the output of this camera. So what I'm going to do, I have several food items on the table, and I'm going to let this camera identify the different type of an object. So let's say I put a hamburger over here, and as you can see on the up left corner, it tries to identify the object and with some confidence score. Depends on the light condition, hopefully it will see hamburger. Yeah, you need to aim at the right angle and with the light. Let's try this donut. Did it say donut? It showed up in donut. Okay. We can also try a sandwich. Okay. Lastly, I'm going to try something exotic. Let's say sushi. Okay. So this is how you could make object classification working by simply running one of the object classification model right on the device. Again, none of these are connected to internet. None of the data is being sent to the cloud or a server. Everything computation happening right on the device. Okay? Great. Thank you. All right, let's switch back to the slides. So now we talk about how do you use a Coral supplied pre-compiled model to deploy that. But what if you want to build something on your own? You want to customize your model. Well, this is what transfer learning comes in. Transfer learning, it is help you saving time in terms of building your own model. And basically, it takes a pre-trained model that is compatible with Edge TPU, and you only take that for your related task by using your own customized data. In a concept, a neural network has many layers deep of neurons. Okay? If you want to train this whole model, in fact, I heard from one of my colleagues who developed a model from ground level up, takes more than 4,000 GPUs to train a vision model, and it takes days. However, if you, instead of train everything, you only need to modify the top layer. This is what a transfer learning concept is. Because the lower layer, those neurons are trying to detect, let's say, different color, different shape, different light conditions. They can be used for you to help you identify things that you care. Let's say you want to build a model, identify different apple. Okay? You don't need to train the whole model. You take a classification model, you only modify the top layer, and by training with your own customized data with many different apples. So this is what transfer learning does. So the code to do transfer learning also in a Python environment on Coral is very, very simple too. Basically, you prepare to do a transfer learning, you set up a Docker container, you specify what model you want to use. In this case, I'm showing an example. I'm using a MobileNet version 1. And if you want to train a few top layers, the single command you want to use is simply start training. And again, you give the parameter as the name of the model. But if you want to train the entire model, you can do that too. is you add one more additional flag, say training whole model flag true. Okay, so once you run that code in a console on your system, basically the console will showing you the progress of a training in terms of the steps it takes and in terms of the number of how much time it takes. So it's very simple for you to do that in the environment, in a Linux environment. So with that, let me do another demo for you. It is called the Teachable machine. We are going to publish this. It's open source for you to do the same in the near future. But basically what you see here, I'm going to show you, I'm going to make a machine to remember things. So the videographer, we need to have an image of this. So on the desk here, what you see, it was built based on this USB with a Raspberry Pi. So, right? So more than Devboard, you could use Raspberry Pi to build an application. So here with this little bit of demo, and it has a camera points up, and I have some different objects, okay? So if I hit a button to take, so every time I hit a button, take an image, let's say, of this hamburger, it remembers several images of this hamburger. Now, if I take a different object and take a different group of photos of the second object, it remembers the images. And I'm going to take ice cream on the green button. And lastly, maybe I take this donut with the red button. So what happens in the background here, the program runs doing a transfer learning. Take an existing object classification model, but replace the last layer with the image that just taken. Okay, now watch this. If I put this hamburger back, the yellow light turns on. It remembers. If I put the ice cream, the green light turns on. I hope you can see on the video, yes. And if I take this donut, the blue light turns on, right? Now, more than that, a moment ago, I trained with this green ice cream, right, the green light. If I put a yellow ice cream, it remembers too. Because this machine learning model, more than just the color, and also identify the shape. Because this shape and this shape is different, the model is smart enough to know the difference between the object. So again, this is one of the examples you could use to building things with the capability of classification right on the device without internet and build even with a small USB key like that, right? Very powerful stuff. Thank you. OK, let's switch back to the slides. So the ramification of this is huge, right? Imagine in an industrial environment, you want to identify things. You want to tell a good widgets from a bad widgets in assembly line, for example. You don't have time to train the assembly line, the auto assorting machine. You could use a transfer learning and learn the different object on the fly, just like that. So it's very powerful. You can use this in building just endless of applications using such capability. All right, so we talk about transfer learning. We talk about building your own customized model. Let me get a bit more detail of how do you use the Coral models, OK? So we talk about we supplied a set of pre-compiled model for you. This is actually case number one, user case number one. It's very simple. You simply download the Coral model we supplied to you. You don't need to compile again. You simply download it and put it on the device. OK? The second scenario is you take an existing model, pre-trained. However, you use transfer learning to customize it with your own data. However, after you've done that, it's not compatible yet with the Coral board. You need to compile. So you use Coral, supply the Coral compiler, and you compile it. The net result of the TensorFlow live file, you download to the Edge TPU hardware, Coral hardware, and you'll be able to run there. Now, I want to say, for right now, the Coral compiler only runs on Google Cloud Platform. But very soon, we will make this compiler a standalone executable, make it downloadable on our internet, and for you guys to use. Third use case is you want to build the entire model by yourself. Okay, this is like you really want to do customization. The existing model doesn't satisfy you. You can do that too. So in that case, you will need, starting with the TensorFlow and the building model from there. So let me talk about the steps involved with there. The workflow of creating your own customized model is the following. TensorFlow model, as you all know, it's a 32-bit floating point model, right? And that is non-usable for Coral because Coral device require TensorFlow Lite. Because it runs on the edge, need a very little memory, so TensorFlow model wouldn't work. You take the TensorFlow model, you convert it into, number one step, you convert it into train with a quantized version. So there's a training process called quantized aware training. You convert your TensorFlow model into a quantized TensorFlow model. Okay? So basically, you convert a 32-bit floating point based to an 8-bit integer-based model. After that, you export this model with TensorFlow model into a TensorFlow frozen graph, which is typically a .pdf file. But this file is not usable either. Okay? It's not quite ready to be deployed on Coral. What you need to do next step is you need to convert this thing into a TensorFlow Lite model and with a TensorFlow Lite converter. And after that, you compile using the TensorFlow Edge TPU TensorFlow compiler and make it into a binary that's compatible with the Edge TPU. And then after you've done that, you deploy it. So this is a process or a flow you will use in your environment. So to build, we talk about how this platform provides you to building AI applications. We said at the very beginning, we want Coral to be a platform of an ecosystem for everybody together. So really, this is a platform for you to use to innovate and share with the community globally all together. With that, I want to show you an example. One of our retail partners called Gravitylink, they built this app, a very cool app. You can use your mobile phone, download the app directly into the Coral Devboard. And you can find more details at this link below, or you just simply search Model Play at Google Play. You can download it and try. So this is the idea of we want all the developers contribute to this ecosystem, building tools, building models, building applications, share with the industry. And this is what a Coral ecosystem is for. OK, with that, let me end by saying, what are the potential areas you could develop for AI, right? Look at this. There's consumer electronics, of course, appliance. There's a lot of opportunities for you to develop there. Industrial warehousing, monitoring the devices, monitoring the assembly line. This is another area. Robotics, both industry and consumer is a field. Automotive industry is also a field. And as all of you here at the Google I/O keynote, medical application, medical devices is another area. And finally, education aids and research. You can use machine learning, on-device machine learning using Coral that you can innovate. So there's a lot of things you could do, right? And all the information I've talked about today, they're all summarized at our Coral website. If you don't remember anything, remember this. It's called coral.withgoogle.com. Our documentation, our samples, models, everything is there. So there's more references I put in my slides. You can look at it later. There's a reference to the Mendo Linux, reference to the TensorFlow Lite. How do you do quantized aware training? And all this information is very important. I do want to call out on Stack Overflow, we have a tag. You can join the online community, participate in discussions, answer other developers' questions, or look at the answers that our team monitoring, right, will help each other using this online community. And I want to give a shout out. We have a Coral Code Lab. For those of you who would like to experiment using Coral at I/O, you can go there today. Our Devboard team colleagues are helping everybody going through the Code Lab. So with that, a quick summary and a call to actions. After you hear today, number one, review our Coral product, learn more about TensorFlow Lite, using Coral Board to experiment, and then building your own customized models, and finally, building model from the ground level up. We want all of you taking Coral platform, put in your imagination, put your innovation, bring AI to the industry, to the consumers everywhere. So with that, on behalf of our Coral team, thank you all very much for coming to this session. Thank you.